Hi, and welcome to the new section, Distributed Computing using Python. The first topic in this section is Introduction to Synchronous Programming. So let's go ahead. The topics that will be covered in this video are: what is synchronous programming, drawbacks of synchronous programming. So let's go ahead. So what exactly is synchronous programming? In synchronous programming, only one task can execute at a time. For example, if two tasks are lined up for execution, then one task will begin executing and the second task has to wait until the first task has finished executing. Only when the first task has finished its execution, then the second task can start. So, in a synchronous programming model, the tasks are basically dependent on each other. What does it mean by dependent? It means that one task cannot start if another task has not ended, or simply it is waiting for input for another task. For example, we have two tasks, task 1 and task 2. So the first task is basically taking input from the user, and the task 2 computes the average of the numbers given as input. So basically, task 2 needs to wait till task 1 has finished its execution. This will be clear with the example. So suppose you have four tasks: task A, task B, task C, task D. So this is the time and this is the CPU state. So the lowest is idle and this is busy. So suppose task 1 starts executing. Now it is waiting for some input from the user. During this time, the CPU remains idle and the other task cannot start. Once it has finished receiving the input, the execution of task A is complete. Then task B starts executing. It again waits for some input or some IO. Then it finishes its execution. Similarly for task C and task D. Now as you can see here, there are blocks where CPU is completely idle. So this is an example of synchronous programming. So basically, one task can execute in memory at a time. So until task A has finished its execution, task B cannot start. Similarly for task C and task D. So what are the drawbacks of synchronous programming? It can lead to idle CPU time, as we have seen. Tasks are blocked if the previous task does not finish its computation. Basically, only one task can execute at a time. So this leads to wastage of CPU resources and time. A quick recap of what we have learned. In synchronous programming, the tasks are dependent on one another. It leads to blocking of function calls and idle CPU time. Only one task execute at a time. That's it for this lecture.